Welcome to the RaRa Academy. Very happy to see you guys all brave the oncoming snow. My name's Tim Brown. I'm the education coordinator trying to put these programs together. And we have Karl, Heinz, Kremer, K5 KHK, who's going to be doing our presentation today on Raspberry Pis. It is being recorded so that it will be posted on our website. So if you missed something or you want to ask a question, you can do that. And Karl's on our board of directors, so his email is available on the RaRa rag if you need to query him directly. A couple things. License classes are coming up starting February 26th at RIT, and anybody who wants to take the initial class, technician, or if you have a friend that does, have them look at our website, and there's a link to my email through education, and they can register for that, and we'll give them information. General class and extra class are also being offered. So all three classes start the 26th of February at RIT. Not exactly sure what the rooms are. We're asking RIT for assignment of rooms this week. Cost of the class, free to members. If you're not a member, join. You get the classes, any classes for free. And the books are $25. I've got them today out in the truck if anybody wanted one today. Coming up, the next academy. There's going to be a change in these academies. We're not always going to be at the BSA here. We're going to rotate them through the, through the county at very public meeting rooms. The next one's going to be out in Ogden at the public library on Ogden Center Road, right at the corner of 259. The topic for that is going to be antennas, both antenna types and design and modeling. I have two people from RDXA coming to speak, and one of them is, both of them are DXers, and one of them has modeled his own antennas, and we'll show you how to use the 4NEC modeling software if you want to play with how an antenna is going to work.
And remember that name, NEC4.
NEC4?
Remember that. We may need that in a few minutes.
Oh, okay. Good. Yes, Chuck?
What's the date for that?
The date for that is February 23rd, 2019 at 10 a.m. at the Ogden Public Library Meeting Hall. It's 269 Ogden Center Road. Take 490 to 531, get off at the Spencerport exit. Instead of going right to the village, go left to the next block, take a left on Ogden Center, and you're right there. It's at the where the public their public service is, their government buildings. So, and I have a sign-up sheet for that. So if you're interested during the program or at the end of it, sign up for that. So I got an idea how many people and how many, if we have any handouts. Okay. Any questions? I thank Scott for recording this, and over to Karl Heinz.
Thank you. So, good morning, everybody, and thanks for making it to this place, even though we have not yet a blizzard out there. So, we'll be talking about Raspberry Pis today. Who has a Raspberry Pi? Okay, so we have a few. Who knows what a Raspberry Pi is? Aren't they delicious? No, this is not exactly what we want to talk about today, but before we start, I just want to set some expectations. I cannot convert you into a Raspberry Pi expert in 2 hours. It's just not possible. Or a Linux expert, for that matter. And what that is more about in a little bit. I can also not teach you everything that there is to know about a Raspberry Pi in 2 hours. Again, not possible. What I hope to do today is whet your appetite so that you say, hey, this Raspberry Pi thing really sounds interesting. Maybe I should read up a little bit more about it, and maybe I should get one and use it for XYZ. And we'll talk about some of these examples, what you can use the Raspberry Pi for towards the end of today's session. So I also want to warn you that some of the stuff that you hear today, if you've never really worked with computers that intimately may sound a little bit frightening, but as long as you have a buddy who knows a little bit more than you do, you are in good shape. And we all are very happy to help you to get started or to cross a threshold or solve problems if need be. So if you get a Raspberry Pi and you run into problems, shoot me an email, talk to me at a meeting, and I hope that I will be able to help you. And if not, I know other people who know a lot more about this stuff, so that at the end we should be able to resolve your problems. So what is a Raspberry Pi? We already said it's not this one. A Raspberry Pi is a real computer for somewhere between $5 and $35. But it comes with BYOKMDP. What does that stand for? Bring your own keyboard, mouse, display, and power. So a Raspberry Pi looks like that. I actually added that orange thing. It's just that green thing, that green board. It's a whole computer on a single board, and that's why we call them single board computers. They come in different shapes and sizes. More about that in a little bit. But it is a real computer. It runs an operating system. It shows windows on your display. You can click, you can move, you can type. For, as I said, somewhere between $5 and $35, depending on what version you want to get. It was created back in 2012 by the Raspberry Pi Foundation in the UK, and their goal was to create a computer to teach basic computer science in schools and developing countries. And then the geeks got a hold of those Raspberry Pis and said, hey, we are not a school, we are not a developing country, but we have great ideas what we can use this device for. And that's where we are today. There are a ton of ideas out there about what you can do with a Pi, a lot of resources, and again, more about that later, to learn about the Pi. So that's why we are here. Again, we're not a school, we're not a developing country, we just have an interest in what we can use a Pi for. Now, about the name. Why is it Raspberry and why Pi? Raspberry goes back to a history of using fruits and vegetables and nut names for computers. We all know about this one here, the apple. There was a tangerine computer in the UK in the 70s. There was an acorn computer. And when they tried to figure out what to name their little computer, they came up with Raspberry. And why Pi? Pi is short for Python. Not the snake, it's a programming language. And we'll talk about that also in a little bit. So I have told you Pis come in a number of different forms and sizes. What we usually refer to as the Raspberry Pi is actually the Raspberry Pi 3, and the latest version is the B+. Or I should say the Raspberry Pi B, and the latest is version 3 and the Plus. When you pay when you pay your $35, that's what you get today, unless somebody's trying to rip you off. It is a 1.4 gigahertz, 64-bit quad-core CPU with 1 gigabyte of RAM. What does that mean? 1.4 gigahertz is the speed, so it's a decent speed for a small computer. 64-bit means it can process a lot of data in a short amount of time. A cheaper version would be a 32-bit version. Quad-core means you actually have 4 different CPUs on that chip, so it can do 4 things at the same time. And it comes with 1 gigabyte of RAM, so that it can do stuff in memory, process things, store things. This is not the disk space, this is just the RAM that it has. Then we have a Raspberry Pi 3A Plus, has fewer I/O ports, output ports, but the specs are the same as here. And then we have the Raspberry Pi Zeros and the Zero Ws. They are slower, they are single core, and they have half the amount of memory. And the Pi Zero is the one that you can get for $5. Again, this is a stripped down version. Doesn't have a network port, doesn't have Wi-Fi or Bluetooth. The Zero W, the W stands for Wi-Fi, does come with Wi-Fi, and that's about $10. So lots to choose from, but if you are just getting into this and you don't have a specific application in mind, I would say go for the Pi 3B Plus. Because everything we talk about today, you can do with that model. And here we have a family picture. This is the B Plus, 3B Plus. And these are two sizes. So they are scaled so that they all have the same size of the output port, which is the same for all these devices. So this is a 3B, 3A, and the Zero. So the Zero is actually quite small, and if you are planning on using it in an application, like you want to automate your garage door, that's probably something that you would buy, because you don't need any of these I/O ports here. Chances are you don't need Wi-Fi. All you need is this port with the I/O lines, and again, we'll talk about that in a little bit. So here is just more information about the family. The processor is based on an ARM architecture, which means it's not the Intel chip that you may know from your Windows PCs or your Macs. It's a different type of CPU, which often is used for embedded applications. And that is actually where they borrowed this CPU from when they designed the Pi. Last year we had a RaRa Academy about an Arduino. Anybody go there? Yes, one? So you may have heard about an Arduino, which kind of looks like a Raspberry Pi. It's a little green board. So is it like an Arduino? No, completely different things. The Arduino is not a full computer. It's a microcontroller that does one thing once you program it. And it does that pretty well. And usually it runs in a loop. So it does the same thing over and over again. It checks inputs, outputs, and then reacts to that. With the Raspberry Pi, we have a real computer that runs applications, that can run your word processing application, can run graphics applications, can run your shack logging application, and so on. So it's a completely different beast, even though it may look very similar on the surface. What they do have in common is that the makers, the people who like to tinker with stuff and build stuff, they like to use both Arduinos and Raspberry Pis, but for different reasons and different purposes. So when I go to the store and buy that thing, and I hook it up to power, it doesn't do a thing. It looks like it's dead, but we know it's a full computer, so what does it need? It needs software. It needs an operating system. So when you take the hard disk away from your Windows PC and start to boot it, it doesn't do anything. It may give you an error message, but other than that, it's a very expensive doorstop. The same thing with the Raspberry Pi, just less expensive and for smaller doors. So we need software. And when you design a computer like this for schools and developing countries, you probably want to make sure that the software that runs on it is cheap or free. if you go to Microsoft and say, hey, we have this great idea, can you sell us Microsoft Windows in large quantities for cheap? They say, yeah, large quantities, yeah, yes, we'll do that, but cheap, no. We are Microsoft. We know what our software is worth. So what these people did, they went out and looked for an alternative to Windows, and they found this Linux operating system. Anybody heard of Linux? Okay. So what is Linux? Actually, we have this on the next slide. It's a Unix-style operating system, and it was created in 1991 by a kid, really a kid, a college student, named Linus Torvalds from Finland, and he did that as part of a college project and wrote a whole operating system. And if you read a little bit about the background story, he just tried to prove somebody wrong. And oftentimes this is how we come up with these great ideas, just to show it to somebody, to stick it to somebody. When you boot Linux, at least the version back then from 1991, it looks just like the old DOS. It's a command line operating system. So you have to type. No windows, no mouse, no easy closing and opening of windows, copying and pasting. It was all done on the command line. And if you want to run the Raspberry Pi, that thing is still in there. And sometimes you actually have to go to the command line and do stuff on the command line. So it actually pays to make the command line your friend again. You can, of course, install the graphical user interface on top of that command line and then have it look almost like Windows, or very similar to Windows. So they took this Linux and they packaged it up and they configured it for the Raspberry Pi and then named it Raspbian. And this Raspbian is available in 3 different, I call it sizes. You get the big one with the graphical user interface and a whole bunch of applications like word processor, drawing programs, image editing, games. Then you get a medium version with just a graphical user interface, no applications. You can still install the applications, they just don't come bundled with the user, with the operating system. And then the lowest level is just the command line interface, and they call this the light version. So if you want to control your garage door with this, chances are you don't want the graphical user interface because you're not connecting a display to it. You want the command line interface so that you can remotely log in and say, okay, what's the status of my garage door? Is it open? Is it closed? And then close it if you left it open by mistake. Now there's one thing that's really, really important when you deal with these Linux or these Unix type operating systems. And the same thing actually applies to your Windows as well. You have to shut it down properly. You don't just pull the plug and say, hey, I'm done with it. Because there's stuff going on. Unlike with the Arduino, where you can do that, because it always does the same thing over and over again, there's a ton of stuff going on your Raspberry Pi or your Windows computer. So when you just pull the plug, it might be in the middle of writing out a file, and then that file is only half written, half is new, half is old, and then when you bring it up again, it's trying to read that, and then it cannot make any sense of what's in that file, and it says, okay, can't do it, and you get, as we know that from Windows, the blue screen of death. We don't have that here. Here we call them core dumps. But the gist is, make sure, if you can, shut it down properly.
What do you call them, do you say? Not, what was the word?
Core dumps.
Core dump
Oh, core dump. Okay, got it.
In the olden days,
with core
computer
memory.
had core
Yeah,
memory.
yeah, really,
Yeah.
I was. That goes back.
And we still call it that. So you have a Pi. Is that it? No. You need a few more things. I already talked about that. You need your own keyboard, mouse, display, and power. You can use a TV, and I actually forgot my TV. I wanted to bring the TV today, just to make sure that you see how it connects to a Raspberry Pi. If you have a TV with an HDMI input, you can hook that up to your Raspberry Pi. And I do that with one of my Pis at home. I have one in the basement, where I have my workbench, and there's an old TV and a little Raspberry Pi and a wireless mouse and keyboard. So you need a USB mouse and keyboard, and then you need a power supply that can deliver at least 2.5 amps for the latest generation of the Raspberry Pis. They don't use 2.5 amps all the time, but once you start hooking up things to it, and we'll talk about that in a little bit, there may be a lot of drain on that power supply, so you have to make sure that you have one that's beefy enough to handle that, and they recommend 2.5 amps. If you have your smartphone charger block thing that you plug into the outlet and then you use a USB cable to hook up the Pi, it may boot, but chances are every now and then it will flicker in the upper right corner a little lightning symbol, which tells you that it has a problem with the voltage level on the input. So it's trying to tell you that, hey, I need a more solid power supply. Yes?
Karl, when I first got the Pi, the power supply that I had didn't have an on and off switch with it.
Mhm.
Now, I see that there's some with on and off switches. Is there an advantage to have an on and off switch? Or
I don't have one with an on and off switch.
Okay.
So I don't think so.
You don't have to unplug it from the wall, but if you like unplugging the wall wart anyways, then
Right, but there's no difference in how you're exiting the system? Or
No.
you still have to shut it down.
You have to shut it down using the software, and I'll
Right.
show that to you in a little bit. So once we have that, I'd like to talk a little bit about USB. When you look at a Pi, it actually has two different types of USB ports. I have one here. When you look at the front, you see 4 regular USB ports, the big ones. And then on the side, there's a micro USB one. The micro one on the side is where you plug in your power supply. So you want a power supply that actually has a micro USB plug so that you can plug it into the Pi. On this side, you plug in your keyboard, your mouse, your GPS, your RTL SDR dongle. I have a few here on my table. Or any other USB device that you want to connect to your Pi. When you want to connect too many power-hungry USB devices here on this side, it makes sense to buy a powered USB hub. That's another way of providing more power to those devices. So if you have a really power-hungry hard disk, for example, a USB hard disk that you want to plug in here, chances are that the Pi is not able to provide enough power for that hard disk, and it will again flash that lightning symbol. Yes?
Yeah, it's interesting that the older Pis, if you plug a Wi-Fi dongle in, they use a lot of power.
Yes.
So mine would not power it.
So again, many USB devices or just one power-hungry device, get a powered USB hub. Your Pi will thank you for that. I just mentioned a disk drive. The Pi does not have a disk in it. So how do we get software on it, or how can we store files on it? I wish I had longer fingernails. This is how we store files. It's a micro SD card. You probably know them from your phones or from digital cameras. They're tiny and they go into the Pi. And you can get them with 8 gigabytes, 16 gigabytes or larger. I have one old Pi here that actually had a big SD card. This was the first generation. All the other ones after that came with micro SD cards. Actually, they don't come with micro SD cards. You have to get one and then install the software on it. Get one that's fast. If you find one in the bottom of a shoebox that has been in your attic for 20 years, it's probably not fast enough. Get a new one. Now here's the problem. SD cards were not designed for what we use them or the way we use them in a Raspberry Pi. Because we write to them all the time and read from them all the time and write again. They were designed for cameras or phones where you have a relatively small number of write operations to that card over its lifetime. So they don't last forever the way we use them in a Raspberry Pi. And because of that, some people actually use external hard disks that they connect to the Pi to store all the important data, and then actually create a read-only operating system partition on that SD card. But that is really digging down deep, and we are not going there today. If you become more and more proficient with the Pi, and this is something that you want to do, there's a lot of information on the internet about that, and I just wanted to throw it out today. Yes.
One thing to mention is that if you go and buy an SD card, watch the size, because you can say, oh, I want to have 128 gigabytes, and you have to go through special provisions to make that work. So you're better off 32 or 64, I don't remember.
I don't know what the current limit is. The largest I have for the Pi is a 32, and that works.
32 is definitely going to be the easiest. It has to do with addressing and stuff, but it's also not very friendly when you start to try to use it. So you'll sit there and fight it.
Yeah.
So start with 32 or less.
I use between 8 and 32 and never had a problem with the size. So that's all you need, as long as your memory card actually contains the operating system and is configured to do something for you. So let's spend a few minutes on how to set up the SD card. How do we actually get that operating system on that card? There are two methods. And up until 2 weeks ago, I completely ignored this method because I'm the geek. I know what I'm doing, and I want to really hear my bits crackle when I write to that card. So for this presentation, I actually looked into this, and this is actually pretty neat. I like it. And it took me a while to figure that out. So there are two methods. One is called the NOOBS, N-O-O-B-S approach, and they call this the new out-of-the-box software approach. The second one is you download an image file and you write that to your memory card using an application that is made for just that purpose. Here, you just copy files. Much simpler. When you go to raspberrypi.org and then click on the downloads link, then this is what you see. You see two big buttons. One is called NOOBS and the other one is called Raspbian. And for the NOOBS system, which is what I now recommend that you should use, you have to format your memory card with the FAT file system. And the chances are actually pretty good when you buy a new card, it's already formatted that way. So you don't have to do anything. If you need to reformat it, go to the raspberrypi.org website and read through their installation instructions. They have a lot of information about how to do that. Then you download the zip file, unzip it, and you just copy and paste the files that are in that zip file to your memory card. And that's it. You insert the card into the Pi, power it up, and it will find all that, and then we'll go through the setup process. And you have to answer a few questions along the way, but that's basically it. And this is how you end up with a working image on your Pi. It takes a while, 15 minutes. Yes?
If you're doing this on a brand new Raspberry Pi, you're doing this offline on a
We
different
do this
computer?
on your Windows computer.
On your Windows computer, that's what I thought.
Do it
Or
on
your
Mac.
Mac if
You
you
do
have a
it on
Mac.
So you don't have to use the SD formatter anymore?
No.
Okay.
No. It's really straightforward and
Okay.
simple, and you end up with exactly the same system that you would have had with the writing of the image to the memory card. There's one difference. The Noob system actually creates a. We have this here. It creates a recovery partition. So if you mess up your system and it doesn't boot anymore, if you started out with the Noob system, you have a recovery partition on that SD card, and you can, by holding down a key, a certain key, and it will tell you what it is, boot into that recovery partition, and then restore your system from there. You can also buy SD cards that actually already have the Raspbian system on it. I would not recommend that because you never know how old that system is. And yes, you can update it to the latest version, but it's so easy to just do it from scratch using that Noob's approach that this really is not a good option anymore. Also, chances are your empty memory card is a lot cheaper than one that comes pre-installed.
And better.
So installing from scratch is not complicated and pretty straightforward. If you go to the website and download that Noob's zip file, it actually gives you all the instructions you need to do that. And I have a few more links towards the end, one actually with a video that shows you how to do it. So if you want to hear the bits crackle, then you can use that direct method of the Raspbian download. But it's a much more involved installation. And again, now that I've done this once, this is a good way to do it. Now during the setup, and this is really important, it's almost as important as shutting your Pi down correctly. You have to make sure that you set the correct keyboard layout. Because remember from one of the first slides, the Pi was designed in the UK. So they default to a UK keyboard layout, which for the basic letters is the same as the US layout. But once it comes to special characters, you have a hard time finding that @ sign or the quotes or the slash or stuff like that, because they are all where they would be on a UK keyboard. So by setting the keyboard layout, and the installation will walk you through that, by setting that to the US layout, you will actually be able to use all those characters that you find on your keyboard. Also set the time zone so that the Pi actually knows what time it is. It will get its time from the internet, but it will get UTC time, and without knowing your time zone, your Pi will run on UTC time. So that's all I had about the Pi as hardware, what it is, how to set it up. Now let's change gears a little bit. But before that, are there any questions? Yes?
Is there no like flash type memory on the Pi such that you always have to boot from the SD card?
Yeah, that is correct. The Pi does not have any flash, any built-in flash. All it has is RAM. So you need the SD card to store things permanently, which also means the operating system, which means you cannot boot it without the SD card.
Where are you purchasing the hardware?
You go to raspberrypi.org and they have links to their resellers. Adafruit is a good place to buy. It's a company in New York City. And I have a link in my resources section at the end about that. So
They have a lot of good support.
yeah.
Who are they?
Fruit.
ADA fruit.
Just wait until the end. I have the name and the link on one of the slides. Yes?
I didn't quite get the advantage of Raspbian operating system compared to the Nubes.
It's the same system. You end up with exactly the same system. It's just a different way of installing
Just
it.
a different installation.
Yeah.
And you're saying the Raspbian is even though it's more complicated, you think it's more
The
complicated?
installation is more complicated.
Yeah.
But what you end up with is exactly the same. It's the same look and feel, it's the same applications.
And why
There's-
choose one?
It's evolved over time. The original ones required you to format the SD card and unzip all your files and image it. So it had like 6 or 7 steps. Now it's down to just a couple. So it's just a matter of being simpler.
And it's also not just a reduction in the number of steps, it's also making those steps easier for somebody who does not have a computer science degree. Yes?
You mentioned 3 different levels of Linux, from the graphical to the basic
Mhm.
one. How do you get those, and how do you differentiate them? You download each one independently, does it cost you?
No, the download is free.
You download that to your PC, and then you're gonna burn the CD?
When you do the Noobs installation, you end up with the graphical user interface. They say, if you want the command line, we think you know what you're doing, and then we'll send you down the other path. So you download the image file and then have to format your SD card in a certain way, download that application that can write to the SD card, and then do all that. So if you want the command line, you need to go the image way and not the Noobs way.
The command line's still there.
It's still
even,
there,
Even
yes.
with the image version, but if you want command line only without all that extra heavy
Yeah.
stuff, which you want for something like the Pi Zero, and it's more advanced.
Yeah.
I,
Is there any, the software that comes with the web part of it?
Mhm.
Or, I'm sorry, with the Windows part of it? Is there any variation on that? I was reading something the other day that said that there's a version of Chrome that can come on some of them, or
It does come with Chrome.
that's on the latest version? So
Yeah.
if I have one now and I just run an update, will it pull that over, or do I have to ask?
You may have to install it by asking for the application.
Well-
We'll talk about that in a couple of minutes. Now,
I assume you're gonna talk also about if I've got a corrupted card, what do I do with that? Do I just chuck it, or can I reformat it?
Reformat it.
you can try to reformat it. If it's really worn out, then it goes into the electronics recycling.
Okay.
but one thing that's kind of cool is if you're going to do something to experiment, make a new card. Because if you wreck it, you just plug the other card in
Right,
and start
right.
over again.
Yeah.
So it's real easy. And also, when you're going on the website, be careful about the deep dive because there's about 20 different versions of operating systems that can be put on the Raspberry Pi. But Noobs is very easy to do.
So here is a little secret. You know what you see here? What does it look like? PowerPoint. It's not. There's Chromium up here.
Right,
See this here? Debian, GNU, Linux, Raspbian.
yeah.
Let me just hide this window here. You recognize this background? This is the background, the Windows background that you get when you install
Okay.
and run a Raspberry Pi. What you see here, what I'm doing here is actually done on the same operating system that runs on the Pi. Just running on the desktop. And you can do that too on Windows and the Mac. If you want the same look and feel on both your desktop and your Pis, you can do that. So let me go back to my web browser. So just to make sure that I'm not that I'm not lying to you. Here I'm bringing up the aprs.fi website, and let's search for and if I could type and see much easier. So I search for K5KHK-1, and let's see where we are with that. So we are just off Brighton Henrietta Town Line Road. What is that here? Is that the Boy Scouts? So you see, that thing knows where I am. So I bring this up in the web browser. I'm sucking this in live. It knows where we are because I have a Raspberry Pi here that's connected to a radio with a GPS, and it's tracking me. More about that later. So this just to make sure that I'm really running inside a web browser. So this is the Chrome web browser called Chromium here. So if, yes?
So you're running Linux on your tablet there, your laptop, right?
I'm actually running it inside a virtual machine on top of macOS.
Okay.
That's a little bit too much.
Yeah.
So let's move on to programming. I said Pi in Raspberry Pi stands for Python. What is Python? It's a programming language, it's a scripting language, and they tried to come up with a good way to introduce people to programming in that Raspberry Pi environment, and they picked Python for that. There is something called the idle development environment that's installed on every Raspberry Pi with a graphical user interface. There are a lot of tutorials out there about learning Python. And then it's just like getting to Carnegie Hall. It's practice, practice, practice. You just play around with it. You give yourself little projects and try to figure out how things work, how you can screw up things when programming in Python, and fixing your bugs and ending up with a little program that does something for you. Python is actually a pretty simple programming language. Here's a little small program. We have for I is a variable in the range of 2, print A, and then a print B. So let me pull up the idle programming environment here on my Pi. So you may not be able to see all this, but I'm now typing in that little program that we had here.
So as a general question, is this compiled, interpreted?
It's interpreted. Actually, I'm in the wrong environment here. So here is my little program. I say run. Why is it not running? Okay. So I did the first part, for I in range 2 print A, and it gave me 2 A's, 2 lines with A's. So that kind of tells me that I in range 2 means do this loop twice. And we can try to see if that actually makes sense by adjusting it. I'm saying 10. And it did it 10 times. So this tells me, yep, my understanding of the loop command is actually working. And I can then move on to playing with a different concept. So let's go back to this little sample program here. An important thing about Python is it forces you to indent your code correctly. What does that mean? If you have any experience with any other programming language, C, Java, Basic, there is no forced indentation. But with Python we have that. So I said this is a loop, and it knows that anything that is indented the same way by the same amount gets added to that loop. In this case I only have one command, the print A. And the print B is actually back at the start of the line. And it uses that information to deduce the structure of your program. But it also forces you to think about how you format your program. And it makes it very easy to say, by just looking at it, yep, everything that's indented a certain way is part of this one block and is part, therefore, of that loop. With other programming languages, we don't have that. Here is the same example in C. When we look at the first one, it looks pretty similar to what we just had with Python. But I can also write it like this, everything in one line. And just because I don't have enough space here, it actually split it up over 2 lines. But this could also all be in one line. It would work exactly the same. But by just reading through that code, it's in your code here compared to what you have here. Or if you get really creative with your coding, again, same thing, but now even an expert programmer looks at that and says, what the heck is going on? You have to really move things around to find that structure again. And Python says, nah, you're not doing that. We will force you to make that right, so that once you look at that program 4 weeks from today again, or half a year, or 2 years from today, you will still be able to understand what you did back then by just looking at the structure of your source code, of your script. Yes?
So is it looking for tabs, or is it looking for a certain number of spaces?
It's either tabs or a certain number of spaces. I can use a tab here, and then use tabs for all my other commands.
A tab counts as 8 or 4 though, so if you mix them up, does it know?
Yeah, you should
If
not
I've
mix
ASCII
them.
32s in, is that gonna mess it up if I used a tab somewhere else and didn't remember?
You should stick to the same method and either use 4 spaces or 8 spaces or 1 tab to have one level of indentation.
What did you press in the shell to make it actually run the program?
I just pushed return twice.
Okay,
So it saw the blank.
So when there's a blank line, it says, okay, you're done typing in the code, run it, okay.
Can subsequent tabs be put under the print A to have, you tab, if you had another instruction, if print B were under print, if you were tabbed over twice,
That would be an error. It all needs to be lined up perfectly.
Okay.
So it's a little bit more work on the programmer. You have to limit yourself, you have to limit your creativity to just the program and not your formatting styles. But once you have that down, it just makes sure that you put that thing away, look at it half a year later, and you still know what you did.
So the colon basically is saying, I am hierarchically going to the next level.
In this
Anytime you
case,
do
with-
that.
With the for loop,
Yeah.
yes.
Yeah. And there's no semicolons and there's no periods.
No,
and
no curly braces. There was a question? Yeah.
So what happens if you tab print B underneath, right under print A? What would you get?
Then
A, B,
it
A,
would-
B, A, B.
It would print A, B, A, B. So this would be part of the same group of the same loop. And it would add that to that, we call it a block.
It's almost like grouping text together in a paper where you'd say, here are my items, column 1, 2, 3, 4, 5, and then go to the next subject. Or I might have 1, 2, 3, 4, 5, and an indent again and go A, B, C, D.
So again, I don't want to teach you programming here. I just wanted to give you an example of what Python code actually looks like. And it takes a little time to wrap your head around it, but it's not a complicated language. And if you have some time, if this is something that you always wanted to try, it's built into the Raspberry Pi. You can of course download Python to your Windows PC and start programming on the Windows in the Windows environment without any problems. But with the Pi, you get it already installed and all set up. So the key is to find a good Python tutorial, and I have a link in my resources at the end. Python also comes with a different programming environment called Scratch, which is a graphical way of programming. You move blocks around that fit together in a certain way, which might be a good introduction to thinking in code, in programming code, for people who want to ease into the programming. If you don't want to just jump right in to the deep end with Python, Scratch may be a good first step to wrap your head around what programming actually is, how you think about a problem, divide it up into different steps, and then try to express that in code. So if this is something that appeals to you, look up Scratch. There are again a lot of resources available online.
So can you run GNU-C under Linux on the Pi if you prefer that?
Can you run?
Just an open source C compiler
Oh, yes.
if you like.
It's actually already on your Pi.
Okay.
You install Raspbian, it comes with the C compiler, and C++. So it's all there.
Didn't use to.
So once you graduate from programming in Python, the world is really open, and you can do whatever you want. So one of the really interesting parts about the Pi is that it has this header here, a 40-pin header with input and output lines that are connected to the processor. And we call this the GPIO port, and that stands for General Purpose Input Output. You can read from these pins and you can write to them using Python, which means that you can hook one of these pins up to something and do something by just writing one line in Python and triggering that line up or down again, and turning something on or something off again, or getting the status of something. You read the state of the line and it tells you, yes, your garage door is open, or no, your garage door is closed. If you play around with hardware, one thing to remember is the Pi uses 3.3 volt logic, unlike the Arduino that uses 5 volt logic. So if you want to hook up an Arduino to a Pi, you have to think about level shifting, making sure that you're only providing safe voltage levels to the Pi, and that the Pi with its 3.3 volt logic can actually trigger something on the 5 volt logic side.
I think some of the Arduino models are 3.3.
Newer ones, yes.
Yeah, so you can pick an Arduino where it works at 3.3.
So here is a picture of what these 40 pins are. We have 3.3 volts, 5 volts, ground, and then a whole bunch of these GPIO lines. Unlike the Arduino, there is no analog in or out here. So this is all digital. If you want to read analog data, then you have to come up with your own way of converting analog to digital. So here is another sample program that blinks an LED in Python. And this is a little bit more complex than what we had before. But one thing that you will recognize right away is we have some stuff that's shifted over here. And from the last example, we know that this is a block that belongs together. And when we look at the line above it, it's a while loop. It says while true, which means, translated into English, ran forever. Run forever. And it will go through this loop again and again and again until you kill it. What we do up here is just setting up the lines as input or output, and then down here we say send a high level to my GPIO output number 8. And then we wait for 1 second, sleep 1, and then we send a low value to the same port, to the same output pin. And then we sleep another second, and then we go back to the beginning, we send the high again. And if we connect an LED to that, then it will look like, where are we? Okay, over here, you see a red LED. Everybody can see that? I have my program here, and I'm starting it now. What's the LED doing? It's blinking, yay! So I said Python, and then I just used the file name here, and this file contains exactly those lines here. And Python is now running this program, and it's blinking my LED. Now, we could make this a little bit more complex and say, let's first read from an input line and see if somebody pushed a switch or a button. And only then will we start to blink the LED. And when they push the button again, we'll stop the blinking. With the Python program that we have here, it's really easy. Or it would be really easy to add that additional logic. We just would not send something to output, we would read from GPIO period input and then provide the pin number. When you go online, yes?
When you get tired of watching it blink, how do you stop it? Control C or?
Yes. So we can just kill it by using Control C.
So conventional Control C.
Yeah. And then it gives us some debug information saying, hey, something just happened. And when you then look through that, it tells you where it was in the sleep call and what happened. It received a keyboard interrupt. So it's spitting out some debug information about, hey, something just happened. I don't know whether this is really what you intended to do, but here is what happened. And when you then go through this line by line, you might be able to figure out what it's trying to tell you. Okay, so when you go online and look at these projects, you'll often find something like this. A really simple diagram about how to hook up something to your Pi. So we have our Pi down here, we have our 40-pin header here, and then if you, after we are done here, come around, you'll see I have a board like this with an LED and a resistor on it. And you will also see that the resistor that I'm using on my board is different than the one that we have in here, because the first one that was close enough I took, which was 120 ohms, this is 100 ohms, and the way you hook this up to your Pi. So no need to read schematics or understand schematics. They have these really simple diagrams that show you how to put something together. And then you just use the software that usually comes with it, and you are ready to go. And if you want to create diagrams like this yourself, this method is called fritzing, and there is an application for that. And it's just like creating your schematics in CAD applications. You download this fritzing application on your Raspberry Pi, or your Windows PC, or your Mac, and then just pick from the modules that they have, like a Raspberry Pi, an Arduino, an LED, a prototype board, and so on, and then you add some wires, and you can document your experiments this way. Now, we all know when we start our Windows PC or when you want to shut it down, oftentimes it's telling us, hey, I'm in the middle of doing some updates. Just wait and wait and wait and wait and wait, and an hour later it's finally done and your system is up to date. How do we do this on the Raspberry Pi? We all know that software ages very fast, so there probably is a need to update software every now and then. The Raspberry Pi is not doing this automatically. You have to actually talk to it and tell it to update the software. And there is a way to do this using the graphical user interface. The way you do it is you just go to your, basically the equivalent of the start menu on the Raspberry Pi, which is up here. And then okay, because I'm not running on a real Pi, it doesn't have that. But there is an add remove software that allows you to update software on an individual package basis. But on a real Raspberry Pi, there is actually a way to update the operating system. There's also a way to do this on the command line by running these two commands. The first one is sudo apt-get apt-get. This is the package manager, which gets an update. Update in this case means it's not getting actually updates of the individual packages, the individual applications. It's updating itself with information from the server about what's currently available, what are the latest releases of the different software packages that we have installed. And then once it has that, you can actually upgrade these packages with the second command, which then will go out and download 35 packages, and it usually tells you this upgrade will add 500 kilobytes to what you've already using on your memory card. Do you really want to do that? And you say yes, and then it keeps on downloading these and installing them, and then you have an updated system.
Sudo is super user do?
Yes.
Super user do, that's how you remember it.
Yeah. It's not one of, what was it, Phil Collins song?
Oh, Sudio, whatever it is.
So sudo is a little trick to elevate your access rights on your Raspberry Pi.
Yep.
We all make mistakes. And because of that, we are usually not running on the Raspberry Pi as the root user, the admin user. We are running as the Pi user or as some other user account that you install, that you set up. For these commands, you actually are modifying the operating system, and you have to tell the operating system that, yes, now I want to have full access to the system. And yes, I do know that if I screw up now, the system may never boot again, and I may have to start from scratch and reinstall the operating system from scratch. So before you use that, think twice about what you're doing, because what you are about to do, the system will just do without any net. If you fall, you will hit the ground hard.
I've never done this before, but is there packages that just will copy an image of the SD card easily, so you can make a backup before you do things?
Yes. Usually the same application that you use to write to the SD card can also read
So
from the
that's
SD
like
card.
SD formatter will do that?
And
or-
will then keep an image file as a backup.
Okay.
But there's also a backup mechanism built into the Raspberry Pi. When you again go to the menu, there's a way to back up your user data. It will not update, or it will not back up the system itself, but it
Just
will
your
back up
files.
your user data. So this is the way to update the Pi on the command line. So again, we have these two commands, update and upgrade. This does not necessarily update everything. And it will tell you that, yes, I did the update and I did update 20 packages, but there were 2 that I did not touch for some obscure reasons, and it's usually not telling us what the reasons are. But what it comes down to is that there usually is a conflict between versions. And there's actually another one of these commands, the sudo apt-get dist for distribution upgrade, that you can add as a third command after the 2 that you've already done, which will then apply a more sophisticated conflict resolution algorithm, and it may actually remove packages. What we've done on the last page here will never actually remove anything from the Pi. It may install new software, or it will upgrade existing packages, but it will never remove anything. This command here may actually remove packages, and that's why they keep this separate, saying, okay, now we can get into trouble. So if you really want to do this, you can, but it's not my problem anymore. If something doesn't work after this, I hope you know how to fix it. So now we have the operating system, and we know how to update the operating system. How about installing software? So I said there are 3 different packages of Raspbian available. One comes with the graphical user interface and applications. If you pick that, then you're in pretty good shape. You have a lot of stuff that you can use, but still, there might be a few packages that are not part of the standard installation. We know ham radio is like a niche hobby. Not everybody is doing it. So chances are they don't have a lot of ham radio applications as part of that standard distribution. So if you want something special, then you have to go out and find that software and install it. So there are 3 different methods, I think, to install software. The most straightforward ones uses, again, the apt-get tool. The one that we saw here. So this is not just a one-trick pony. It does a lot of different things related all to the setup, the software setup of your Pi. So if you know that you want to download, what was that antenna application designing software called? NEC4? NEC? NEC?
NEC4.
So if you want NEC installed, actually you cannot get NEC4 for the Pi, you can get NEC2. If you know the application's name, you can use apt-get install, sudo apt-get install, and then the package name, and it will go out, get that package, and install it. It will also figure out what other packages this package relies on. NEC relies on some math routines, which may not be part of your regular Pi installation. So it may download some other libraries that this package relies on and install those packages as well. You don't have to use the command line. There is actually a graphical front end for apt-get, so that you can actually pick just from a list. And I can show you this here. We'll bring this up again. Come on, why is it? I have to be really accurate in hitting that button. So we use add remove software. And this is what would come up on your Pi as well. Up here we have a search bar. So I'm typing in antenna. And then it's going out and it's finding antenna related software packages. Antenna radiation pattern visualization software. Sounds pretty good. I have no idea what that is. Janice, I don't want that. So if we go down the list, I'm pretty sure we will find NEC. NEC. So I can pick that, install it, and then that application will be available on my computer. Now, let's just search for ham radio and see what comes up. Okay, a lot of stuff that does not necessarily have to do with ham radio. It may be that the ham radio software relies on some of these packages, but here we have APRS, Digipeater, and iGate. APRS, I know that, so that definitely has to do with ham radio. Ham radio packet utility, AX25. And as you can see here with our scroll bar, this is a lot of packages. This little piece here is all that we see. So there are probably hundreds of packages that we can go through and pick and choose from. And there's some pretty interesting stuff out there. They also have some groupings that they provide. We have multimedia, we have publishing. If we want to publish a book and we need software to write that book, Janice R, we'll find it in here. Science, lots of science-related things. Games, if you just want to kill a few minutes by playing a game, there are a lot of games available for the Pi, and so on. So it makes sense to, once you have your Pi, explore that software list a little bit and see what you find. Yes?
Is there a ham radio Raspberry Pi users group on either Google or Yahoo?
Yes. Just wait to the end. This is part of my list of resources. I came prepared.
Couple of questions. Is there any chance of getting malicious stuff off of a list here? Or is it digitally signed? I mean, do you?
It comes from a server that hopefully is controlled by the people who know what they're doing. But it's always possible that something can sneak in. But based on history, I think the threat level is a lot less here than what we have to deal
So
with.
but if it looks like if it fits, but you've never heard of it before, maybe go search on the internet first before installing it. And the second question is there ever any issues, I mean, this has been an issue with Linux for a long time, of conflicting underlying pieces of software with their versions?
Oh, yes.
Yeah, so, okay, so that still exists here.
It still exists, but all the stuff that you find here is compiled and packaged for Raspbian.
So
this
it's
will
harmonized to
all
a certain
fit.
degree?
Yeah,
Yeah, okay,
this will
good.
all fit, this will all install without any problems. Once we get to a different way of installing software, there's more risk involved in mixing and matching things that may not be compatible with each other. There was another question? Yep.
Do you know what shell this is running?
What shell?
Yeah.
Bash?
Oh, it's bash shell.
Yep.
Okay, and does it know, it's probably a package, but does it know IP chains or IP filters? Are you aware of those?
Oh, you mean for firewalls?
For firewall?
Yeah. Yes.
Okay.
You can install a firewall on your Raspbian.
Yes, they are spelled differently, they are different words. Okay, anybody else want to?
Yeah, nothing, at least on this first page. But IP filters is part of Linux. Anything that is part of Linux is available here.
Excellent, thank you.
And it's just a matter of finding it. So this is, again, the most straightforward way to install software, either using apt-get install or the graphical front end for it. The big advantage of the graphical user interface is that you can search. And Yes, sometimes you may have to go through a long list of hits, but it allows you to really explore that repository of available software and say, yep, this looks interesting, let me just play around with that for half an hour. There's a different way of installing software that you would use once there is no package, no formal package available of that software for your Pi. So I call this some lower level processes that we then would have to use. Sometimes you find a DPK file available. For example, if you want to install WSJT-X and you go to the Princeton site that hosts their software, they don't have a file that is made for our package system directly. So you download this EPK file for your Raspberry Pi. And then if you bring up the file manager on your Raspberry Pi, where you can navigate through the different folders and look at the files, double click on files, and double click on that file, it will know what to do with it and will then install it. There's also a way to do this on the command line, but that's where it gets a little bit more involved. If that also doesn't work, then we really have to
Go old
start
school.
doing our own package management by compiling software. And this is where you can get in trouble because, again, nobody's protecting us from ourselves. I have an example, again, linked to at the end, about an application called Freak Show, which is actually running here on one of my Pis that has a LCD screen, and it's hooked up to a radio dongle, and it's showing a frequency spectrum. And I did mention Adafruit before. This is software from Adafruit, and they do sell the Raspberry Pis, they do sell the LCD screens, but they also provide a ton of information related and unrelated to the products that they sell. So if you want to figure out, learn about how you could potentially install software from scratch by compiling it yourself, take a look at their tutorial about this application, because they go through a number of different things that they do to get that software to work. They do install using the apt-get install method as much as they can, and then they download software from the Git software repository server, bring it down, and then run a bunch of commands to compile that. Again, this is not a class about how to program for your Pi or how to get deep down into trouble. Because of that, I'm just referring to their tutorial, which is pretty good, and it shows you what the different steps that could potentially be involved are. So, we have about 45 minutes left. That's all I wanted to talk about the Pi as this abstract thing. From now on, we'll talk about concrete examples of what you can do with a Pi. But before we do that, are there any questions? Yes?
Do you run an antivirus program on your Pi?
No.
No need to then?
I'm not even sure whether there is one. Again, as I said before, the threat level that we are dealing with here is a lot less than on the Windows side, just because of the numbers. If you want to get your bad software out there, you target the operating system that has a much higher likelihood of distributing whatever it is that you want to get out there. And you target Windows or the Mac if you really want to. But this is stuff that is really rare to find on the internet compared to the number of Windows PCs that are out there. And then you have the problem that a lot of Pi is actually set up completely different from all the others. So your your approach to target a known environment is a lot harder when it comes to the Pi versus when it comes to the Windows systems. Most Windows systems are set up the same way. They have the same software, they have the same applications installed, and oftentimes the same lax handling of security processes by their owners. So they leave the door wide open and they click on everything like crazy that looks shiny or blinking or colorful, and that's how we get into trouble. On the Pi, I don't think it's a big problem. At least I've never heard of any problems.
But do keep up to date.
Yes, it's always good to keep up to date with your software.
Because you can end up with some of the vulnerabilities over the last 10 years. Heartbleed was one of them, I think. Probably would be on here as well. They have to do with the front end, with the way it handles internet traffic and stuff like that. So,
Having it on, I'm sorry.
Go ahead.
Having it on your computer network at home, if I've got running this headless, there's no real risk for me running it 24/7 then.
I don't know how many Pis running 24/7.
Okay.
And we'll talk about that in a minute.
Okay.
Without any problems.
they have to
Besides-
get through your router to get to your Pi.
Right.
Yeah.
The only way you usually get stuff is when you go off and actually install something inadvertently by clicking on the shiny thing in your browser.
Yes.
If you're gonna be running a lot of sudo commands,
Mhm.
is there a way to get into super user mode such that you can only have to type a command without the sudo?
Sudo su. Sudo space su.
Oh, okay.
And that gives you a root shell.
And then how do you get out of that exit?
You pull the power plug. No. Yes, exit.
I have a question that's on the GPIO pins and the operating system. How fast can you drive them, and how responsive are they, and how
Okay.
much does the operating system get in your way when you're trying to do something that's timed?
Let me
Or do you cover that later?
Yeah, let me come back to that in a little bit,
Okay.
because I have one application here that runs really, really fast.
Okay.
So, if we don't have any other questions, let's talk about some of these applications that I have here. And the first one that I want to talk about is this freq show. Shows the frequency spectrum using an RTL SDR dongle. Does anybody know what that is? Okay, some of you. They look like this. Just a dongle with a USB cable connected to it, and they come in different sizes. They go back to receivers, computer receivers for TV in Europe. They figured out how to put a TV receiver into a little dongle, and you would connect that to your computer, and then you could watch TV on your computer. And because they use a different TV system in Europe than what we use here, you cannot watch TV with those here. But somebody figured out how to reprogram them. And we can now use them as general purpose radio receivers from about 24 megahertz to 1.4, 1.8, 2.1 gigahertz, depending on which version you have. And you can receive radio signals in that spectrum. And when I say radio signals, that means any type of modulation. SSB, FM, CW, digital modes, whatever is out there, we can process, because it's all done in the software. That little dongle just provides information about what those signals look like, and then SDR stands for software defined receiver. The software takes over and does something with that information, and then on your speaker you hear SSB, FM, or Morse code. So in this case, we're using this to show a frequency spectrum. And we're adding an LCD touchscreen, and anything that plugs into that GPIO header, an extension board, we call it a Pi hat, because it sits like a hat on top of your Pi. And it does require that we install software using the software package manager, but also compile and install software on our own. And I ran out of time last night when I was setting this up. I was actually trying to demonstrate how you can show a frequency response of a filter. I have a filter here, I have a noise generator here, attenuator here, and then hook that up to the dongle. But I grabbed the wrong filter. This is a 40 meter band filter, 7 megahertz. I said these go from 24 to gigahertz. So you can't really see anything. But in general, I've used that before to look at filter characteristics, and it's pretty nice because you can see it right here on the display. And this is a touch screen. I can tap on it and it does different things. I can change my frequency, for example, to something different. And all done with a Raspberry Pi and the touchscreen and a dongle which you can get for $10 or $20 online.
Just a comment on that, you can put an up converter between
Yes,
your
you can.
antenna or your filter and the dongle.
And actually with this one you don't even need the up converter because it does have the direct conversion method, but then you have to actually change the software to switch it into that. And again, I ran out of time. So this is my first example. Second one, an APRS tracker. So I did show you on the web browser that it is actually tracking me. This was last updated 10/24, so an hour ago. I guess these walls are pretty tight. What I have here is actually self-contained. So it's not connected to anything. I have a power bank that powers my Raspberry Pi. I have a little adapter board that takes information from an audio card, which is here, that blinking thing, and connects that to my HT. And in addition to that, you see the purple wire here. This is one GPIO output port that then controls PTT on the radio. So when I'm moving, depending on how fast I move, it sends out a position update every minute and a half, every minute, and a maximum if I move really fast every 15 seconds. If I'm not moving, then it sends out an update every 15 minutes. And it looks like the last couple of updates did not go through, probably because of all the concrete in the walls. So this GPIO port, you may see the white toroid here. Raspberry Pis are pretty sensitive to HF or RF in general. So you can actually make that reboot by keying the transmitter if you have long wires on it. And I have another ferrite here on the cable that goes to the HT to block some of that RF to get into my Pi. And I had to add that toroid here because it was really rebooting every time I keyed, or it keyed itself. So this was actually a reboot program. Every time it tried to key the transmitter, it rebooted the Pi.
Would it be better to package that in a larger RFI package so that
Yes.
you're not doing that and grounding, or at least connecting the shields?
Yes, but I do like my rubber band and duct tape approach.
And your reboot.
Yes, and it doesn't do that anymore. Oh, and the other thing I have connected here is a GPS dongle. It may also be that we're not getting any GPS signal in here, which is probably more likely. So,
So there's no APRS in the radio, that's,
It's-
it's getting a GPS?
it's all done here, yes.
And the power supply you're using there, Karl, is that?
It's a 5-volt power bank that you would use to recharge your phone
Okay.
when you are out in the middle of nowhere.
So is the serial being run through the USB then? To the APRS modulation stuff, or is it,
The only serial port here is from the GPS to the
okay,
everything else is done inside the Pi, all in software. And out comes just the audio. And in goes the audio as well.
okay.
So it's actually, it's receiving as
So
well.
it's actually doing all the modulation in the
Yeah,
Pi itself?
yeah.
Okay.
And it's done with a package called Dire Wolf. And we have that on one of the slides, or probably several of the slides. Just find them again. So we use the GPS to determine our position and then send that information out using our HT. We need to interface the audio with the HT. That's my little board here. There's a little transistor on it, a couple of resistors and LED. The Raspberry Pi only has an audio output, which for this purpose would be fine because all we want to do is send audio out to the HT. But if we want to also get audio into the Pi, then we need an external audio interface. And in this case, because I don't want to just transmit over somebody else transmitting, I want to make sure that I'm transmitting once the frequency is clear. I actually listen to what's coming in, and then the software only transmits when there's no carrier. We need the GPIO to control PTT, and I'm using the Direwolf as the main software to handle the tracking. And there are actually detailed instructions for how to set this up in the Direwolf documentation. Direwolf runs on all sorts of Unix type systems or Linux type systems, not just on the Raspberry Pi, but they do have documentation specifically for how to set this up on the Pi. So with that, you can see on aprs.fi, the website, where you are if you get lost.
Where your family can track you.
Yes. APRS receive-only gateway. So what we have here, of course, with the HT using just a couple of watts, that signal doesn't travel far to that server that is located somewhere. We need some sort of gateway that can receive us and then take that information, send it out on the internet, or relay it again on the radio. And we can do this with this APRS receive-only gateway. So it doesn't transmit anything, it only receives. And again, it uses an RTL-SDR dongle. Where is it? I guess when I go back from my antenna, I should be able to find it. Here it is, connected to the same Pi that was blinking the LED, which tells you that it can do multiple things at the same time. So this is receiving APRS traffic over the air, and then taking that and sending it out on the internet, forwarding it to some other machine somewhere that can handle it. So if everybody would have one of these in their houses, you could drive around wherever you are, and your APRS tracker could always be able to send that signal out, and it would end up on the map. Because when you are in not very densely populated areas, chances are that these are very rare. You probably also have a lot of black holes out there where you drive and nobody knows where you are. So by just using a Raspberry Pi, $10 dongle and an antenna on a very convenient Mint box, you can help people with these trackers to get their signal out.
So the dongle you have, is that a generic dongle, or
Yep.
have to be specific to any particular?
No, it's generic and they come again in different sizes, different configurations. There needs to be a certain chip in there, but all of them that you can buy on eBay for just a few bucks have the same chip. So again, it uses Direwolf to do all the heavy lifting here. And all you do is write a configuration file for Direwolf where you explain what you want it to do. Whisper. Who knows what Whisper is? Okay, we have a few here. Whisper is a way to get an idea about how far your signals travel. It's a weak signal mode developed by the same guy who developed FT8. And Whisper has been around for a while. And what you do is you send out a very narrow band signal that's modulated very slowly over a 2-minute period. And there are a ton of Whisper receivers all over the world. And once they receive your signal, they upload that to the WhisperNet, where you can then go and say, hey, how far did my signal travel? And usually you have to take one of your transceivers and dedicate it to that for that amount of time that you want to get that information back from other people. Now, with the Raspberry Pi, we can actually do something really interesting. The Raspberry Pi can transmit. And just to answer your question about how fast can you actually trigger those GPIO signals, you can easily create 2-meter signals with the Raspberry Pi, frequency modulated, and then by just hooking up a piece of wire to one of these GPIO ports, transmit. And that's what I'm doing here with my original Raspberry Pi. It is connected to a piece of wire which goes around the room here, but chances are nothing that I've been doing in here is getting out. And it's transmitting on 20 meters. And when you think about creating HF signals, modulated signals, by just turning a GPIO line that can only go from 0 to 3.3 volts on and off, you can probably imagine that that signal is pretty dirty. It has harmonics that go into the gigahertzes, because that's what happens whenever we have a true square wave, which is basically what we produce here. So that means you have to filter that signal every time you connect more than just an inch of wire to that GPIO pin. So on this Pi here, I actually have a low-pass filter board for 20 meters that, in addition to just filtering, also provides a little bit of amplification. And then with just a piece of wire, this signal has been copied in Europe, in Asia, and of course all around the US. And it's all done with just a Raspberry Pi, no transmitter involved.
And there's no issues with background tasks or other things going on in the Pi interrupting the,
No, at least not so far with my setup. Now, chances are you can bog down the processor with other stuff that it would not be able to do the same. Again, this is the first Pi that came out, so this is
Yeah.
a slow one.
and that's, you're doing that in Python? That's not with Python?
No,
Assembly
it's
language?
actually a C program that's compiled.
Oh, okay.
So you can, rather than using a $500 HF transceiver, you can use a $35 Raspberry Pi.
Yes,
and a few other-
actually $5 one. This would also work with the Raspberry Pi Zero.
And use that as sort of your transmitting beacon.
Yep.
Continuously, all you do is write a repetitive program
Yep.
to send your calls on.
There is actually software out there that you just download. So down here, these people sold me the low-pass filter board, but the documentation has information about all the software that you can run on this. And this is SSB, FSQ, narrowband FM, AM, Whisper, CW, SSTV. They have links to all these packages that produce all these modulation types. And then you just install it, run it, and for the Whisper configuration, you put your call sign in a configuration file or on the command line, and then it knows who you are, where you are. You also tell it how powerful your transmitter is. And then that information gets sent out with the Whisper signal. So you can do pretty interesting stuff here with these different modulation types. There's also a frequency sweep. If you just need to sweep the Pi from, let's say, 1 megahertz to 30 megahertz, and then watch for that signal with something else that you're working on, for example. There's software here to do that. I've created my own 6-meter low-pass filter that I hooked up to the Pi, and I got picked up by a couple of stations in this area.
I couldn't hear you. Where was this?
It's louder, just say it again louder.
I created a 6-meter low-pass filter that I hooked up to this setup here, and send out a 6-meter whisper signal. Didn't get very far, but I got picked up by a few stations in this area, so locally.
Would it be possible to do that in some sort of mobile configuration also? So you could drive in your car and sending a whisper signal out?
The only problem is you need your grid square that goes into the configuration for the signal, so that gets sent out. But again, you hook up a GPS,
Right.
and you have access to that. So you can dynamically update your grid square, and that's a great way to use your newly acquired Python skills and rewrite that configuration file every now
So
and
you
then.
haven't done that, that's what you're saying?
No, I haven't. This is only the second place this has worked. I usually have it in my office. Okay, so Whisper Transmitter was another application for a Raspberry Pi. FLDigi and WSJT-X. When I first got into ham radio again after a big break of more than 20 years, I didn't have an antenna. I still have my old rig, but I didn't have an antenna. So what did I do? I hooked up my rig via a tuner to my ring girders. And the ring girders were like, I don't know, 3 feet away from my head when I was operating the rig. So I didn't want to blast out 100 watts there. So I limited myself to weak signal modes, and I did WSJT-X and did FT8 with it. And I used a Raspberry Pi for that. So I hooked up a Pi to a sound card, the sound card to the radio, rigged up a pretty crazy way of triggering PTT on the radio with a serial port, and then used my Raspberry Pi for FT8 work. And I got, I don't know how many contacts, 50 states in almost no time. And then once I graduated to a better antenna, I never looked back at that FT8 again, because then I had access to all of the fun modes. But it got me started, and it was fun to do it, and it was also fun to figure out how I could do all that with the Raspberry Pi. And I have a little setup here where I have a radio in this aluminum box, which is a software-defined radio, direct sampling, that needs to be hooked up to a PC anyways, and I have a different Pi here, which is not a Raspberry Pi, more about that in a little bit, that runs Quisk software, which oh, look at this. This is my whisper signal. See this peak? This is the whisper signal that's going out through the wire, and I'm picking this up through my magnetic loop here. Wireless. It's working. A whole bunch of Pis, wires and no wires, and we can see the signal that goes from one system to the other. So, since then, as I said, I moved on from FT8. I did some PSK31 using FLDigi on the Pi as well. So you need a USB audio interface. And yes, you can go out and buy the signaling interfaces for a lot of money, but you can also just get, I have too much stuff here. Where is my USB done? So here is my USB audio interface, the blinking thing here. That probably was $4 on eBay, straight from China, including shipping. So don't get anything expensive, even the cheap crap from China works. It's just a matter of figuring out how to use it. The audio stuff is usually pretty easy. When it gets a little bit more complicated is how to control PTT. And that's why you either use a serial interface, a serial USB interface, or you use cat control if your rig supports that. So in this case, there is actually cat control built into the software that I'm running here. So my Raspberry Pi can talk over the wire to the software here and then control the rig. Yes?
What was that software again? You said Quisk?
Quisk, which is
You have a reference
software
to it on the end?
for... No, I don't think I have anything for that, because that's very specific for a certain type of radio. If you have an SDR radio, like the soft rock that we had a RaRa Academy about last year, that would be a type of radio that would work with Quisk. In this case, this Hermes Light 2 also works with Quisk, but chances are if you have a radio that supports Quisk, you would know about that. So when you do this, because you are dealing again with Wi-Fi, with RF and Raspberry Pis, and we know the Pis do not like RF very much, you may actually need some ferrite cores again to block RF from getting into the Pis. I think this is everything that I have here on the table. There are a few other things that I wanted to talk about that you can use a Pi in your ham shack. One is a signal generator. We already talked about using the Pi as an RF signal generator. You can also use the Pi to create audio frequencies. There is a signal generator that you can download using the regular Pi configuration or software download application that we looked at before. Just search for signal generator, and it can produce two different tones. You specify the frequencies, you specify a phase shift if you want to. You can do a digital audio card-based oscilloscope, again for audio frequencies, and see the signal on your screen. You can do something really interesting, and this is actually something that got me back into ham radio after, I said, more than 20 years away from it. ADSB flight tracking using software that runs on a pipe. Every airplane that's up there sends out information about what it is and where it is. Altitude, speed, and position. Using this ADSB system. And it's all out there. It's just a matter of picking it up. It's at 1090 megahertz, and it's just a matter of having a radio that can pick that signal up. And our dongles, RTL SDR dongles, they can certainly do that. As I said, 24 to 1.2, 1.4, 2.1 gigahertz. That 1 gigahertz frequency is right within their capabilities. So we can actually go out and hook up one of these to our Pi, and then if we have the software, we can download or receive that position data from the airplanes and do something with it. For example, just look at it and be amazed about how many airplanes are out there. Let me just see if I can do this quickly. I have one of these at home. This is the one of two Pis I did not bring today. It's sitting in my office, connected to a little antenna, and it's receiving that signal, and then it's relaying that out to a service called Flight Aware. And by doing that, I'm actually getting the Flight Aware premium customer account, which means that if I'm traveling on an airplane, I get all the information about that flight through Flight Aware, where it comes from, what the connecting flights are, any delays, the current status, where it is, and so on. But it's also just interesting to look at the data. Let me see if I have this.
Basically, all airplanes that fly in controlled airspace have to be ADS-B
Yes.
by next year. I'm pretty sure almost all the commercial ones have been for a while.
So now I'm logged into a computer at home, and here is my Pi Aware Sky View. So this software, this web page, is actually coming from a Raspberry Pi in my office. And right now you see there are 3 airplanes here, which actually is not a lot.
Weather's not so hot.
Yeah. And when you watch them, you can actually see them move. And this is real-time information. Usually when you use one of those flight trackers online, they give you a 5 to 10 minute delay, so that you cannot use that information to say, yep, that airplane is here, let's shoot it down. Here you get real-time information. It tells you exactly where that airplane is, the track it went on, and also some information about where it's going, where it's coming from.
So you're sharing this with a lot of other people who are doing the same thing then with Flight
Yes.
Aware?
Yeah.
Yeah. So you're dumping your data in and they're looking at it and you're looking at their data as well?
Yeah. Actually, when I want to look at other people's data, I do get that 5 minute delay.
Okay.
It's just my data that is
Real time.
So, very interesting
So
way
just one
to-
comment on that. He he gets the data when the transponder on the airplane is pinged by something like the Rochester radar. Okay.
No, they are sending this out.
Not continuous.
I'm not sure.
It used to be, it's attached to the transponders on some
Yeah.
models. I don't know,
I
there's
think it has to
different
be-
modes.
I think it has to be interrogated by something that's part of the air traffic control, and then you get the response off of it. You can't ping it.
No, I can't
You
ping
get
it.
big trouble.
No, you
I
can't.
can only listen and.
I think TCAS also pings it as well,
So that's one of the things that's kind of been an evolving topic in regards to drones and things like that, is whether or not you have to put ADS-B on it by a certain date, and, depending on where you're operating. And so the concern is you're gonna have 50 million drones pinging all the ADS-B systems on the commercial airliners, and they don't want that.
So, until we get to that point where there are just too many signals out there, right now, airplanes is all you get. And again, just a few bucks of investment to do that.
So I guess kind of subtly, if you were over the middle of the Atlantic Ocean and they're outside of radar, you won't pick up their ADS-B.
Okay.
'Cause
I know,
it's not-
does TCAS do interrogation? I thought I worked with TCAS as well. So if there isn't any, secondary radar, I guess, that's interrogation. I don't know. I read about it all the time, but don't fly anymore, so it's like,
And I'm not too much into it, so there's a
Yeah.
lot of information out there about how it works, but
a lot of grumbling about how much it costs to put it into smaller airplanes.
next one is RTL 433. We've all probably have experience with wireless thermometers or weather stations or garage door openers or other devices that work wirelessly. Chances are that they all transmit in the 433 megahertz band. And we can, of course, again, capture that information using a dongle. And I have a weather station on my roof that sends data to a little display, but then it doesn't go anywhere from that display. And if I'm not in my kitchen, I don't know how strong the wind is blowing or how much rain we've gotten or what the temperature is. So there's software out there, RTL 433, that can actually hook into that and receive that information. And then with a Python script, you can do whatever you want with that information. And I take that information from my weather station and I am uploading it to Weather Underground. And I can actually look at that data on their web page, and then I should have saved the bookmark for that. Okay, can't pull it up right now, but in theory, I could look at the current data, the current conditions at my house, and then the history going back, and pick any day and say, okay, how much rain did we get on August 17th last year? Yes?
So your Raspberry Pi is hooked up through Wi-Fi to the internet, uploading the
Yes.
data to Weather Underground.
Yeah, so that's the second Pi that I did not bring today. Other than that, all my Pis are here. So these two Pis are actually doing work at home right now. So again, very interesting to just pick up that data and then do something with it. Then there are DMR hotspots. And this is an area that I have no experience with, so that's why I didn't talk about it, and I just listed here. If this is something that you want to do, Mike Moore is the guy who knows much more about this.
What does that stand for? DMR?
Digital mode radio, I think. It's Motorola's digital mode. Basically, the hotspot is, usually it's a Pi with a Pi hat on it, and then the software, and then it'll run DMR, it'll run D-Star, it'll run all kinds of different things, depending on what it is. And the transmitters, I understand, are pretty dirty, but they're good for, because they're only use them around your property.
Yeah, they are a watt or less.
Yeah.
Does
But-
that use hi-fi, Wi-Fi also?
You can use that or be wired, either or. But you configure it via a web page. At least you do with the one I have. And it hooks up to, I don't remember the name. There's a site that manages a lot of the DMR stuff, but it's a whole different topic.
Brandmeister.
Yeah, Brandmeister, yeah. It had kind of a weird, it almost sounded like a beer, you know.
Yeah. And then last one here is interface for digital modes, and these are heads again. There's a DRAWS device. Don't remember what exactly it stands for. It's a head that goes on top of your Pi, has audio interfaces, has a GPS built in, and you can hook that up to your radio, and then use the Pi with your radio for all sorts of stuff. Yes.
Digital radio amateur workstation.
Thank you. And then MFJ is working on something similar called the Rig Pi, which has audio interfaces and a keyer for CW built in, again, hooked up to your Pi. And they also give you remote access, remote audio access to your rig. So you can be on your phone with special software installed on your phone and then control your rig at home and make contacts. I said this is not a Raspberry Pi, this is actually a Nano Pi. So there are other Pis out there that are similar. There are also single board computers. Some of them have actually the same GPIO port layout, that 40-pin header. So software that you write for the Pi can then easily be adopted and moved to the kind of Pi. Some are faster, some are cheaper, some have built-in memory. So some of these have built-in flash memory. You don't need the SD memory card. Some of them have more cores. This one actually has 8 cores. But the community around the Raspberry Pi is definitely the largest. So if you want to get started with something, the Pi is a good device to start with, because there are a ton of people out there who are posting ideas about what to do with the Pi, participating in discussion forums, and are also willing to help you if you run into problems. With some of these more exotic Pis, you better know already what you are doing, because chances are you will have a hard time finding somebody who can help you with that device. I have 2 other ones here. One is the chip, which was marketed as the $9 computer. So again, small single board computer, different pin setup here. We have 2 rows of pins actually. This company went bankrupt a while ago, so unfortunately you can't get them anymore. They also made this, which is a pocket chip, which is a chip in the background, and then an LCD display and a very crude keyboard. So you have a Unix workstation in your back pocket, if your back pocket is big enough, the pocket chip. Pine 64, something similar again, different layout of I/O ports, and can't remember exactly what the advantage of this one was. Bought it a long time ago. So here we have a long list of resources. I don't want to go through all of them. You can just download the presentation. I'll get the PDF file to start. You can put it up on the website, and then you can download it and have access to all of that. The official Raspberry Pi website is full of good information, raspberrypi.org. MagPi, that's one thing I want to talk about. It's a magazine published by these guys. You can buy it in print, but they make every issue available for free download. Lots of information in those, so you can go back 77 issues and read everything about the Pi that there is to know. But they also have books. They have a beginner's guide and a project book series. The volume 3 of the project books has an excellent Python tutorial. So if this is something that you want to get into, download this free book and work through the tutorial. Adafruit, I've mentioned, great company to do business with. And then a ton of other resources.
You could have
And
to go
that's
through that
the end.
slower if anyone's going to see it on the video.
Oh.
Can leave it up for a moment. Go back to that one and then give it a moment. I'll zoom in.
Okay.
I already got that one.
And I only went over by 4 minutes.
Thank you. That was excellent.
So, thank you very much. They can come view all your
Yes.
stuff and talk to you. We don't have to exit the room immediately. I do have some announcements I do want to make. Anybody, I have sign-up sheets in the back for the Antenna Academy that's coming up February 23rd at the Ogden Library. It's going to be a great presentation by a couple of people from RDXA. We've got a lot of experience with antennas and on modeling. And I'm going to have some hardware there to show you, if you're a basic person want to know how to put up an antenna, show you some of the things you can use to put up wire antennas. I'm a wire antenna guy. The March Academy will be held at the Pittsford Community Center. We're moving these academies around, and that's going to be presented by Scott. And Scott's going to be talking about electronic components and testing equipment and testing these components in circuit and out of circuit. So it should be interesting for anybody that's a kit builder or a project person. You're going to build some of these things yourself. We go hand in hand with that. The radio, the Rochester Xerox CW group has started up, and people that know Morse code can get advance their speeds. We've got two groups that of novices. One meets at my house, the West Side group. Another one meets on the South Side, and you can learn Morse code. And I talked to a few of you about a Wednesday. I'm busy this Wednesday, so the next meeting at my home is going to be on Sunday the 27th, Sunday afternoon, 1 p.m. And I'm not sure when Super Bowl is, so I'm going to avoid that Sunday. And if you want to learn Morse code, you don't know it, then by all means contact Forrest Schick, who's in the RaRa Rag. He's the coordinator for all this. Yes.
I just want to add, it's a very supportive group. We've covered a lot of ground on the south side. If you're at all interested, please jump in. So it's a really great program. And I commend you and Forrest and the group for pulling that together.
And it's also on the web at
We've got a link.
the RxCWG on the left side banner under Learn. So there's a whole web page now devoted to this with resources. We posted one video so far.
Most of you have got access to the rag or should be getting it. We have one new gentleman here that gave me his email address, and I'll make sure you get that on that distribution. Anybody else that doesn't get the rag or isn't a RaRa member, let me know, and I'll make sure you get that information. Lastly, VHF contest is this weekend. If you want, you want to get on and operate, people get together at 8 p.m. and 8 a.m. as a standard type thing, just so you know there's going to be people on. It's run all day. In fact, there's a group down in Mendon Ponds right now with the Boy Scouts at Klondike. They're going to be running K2JD, our contest station down there. Mike Moore is down there, who's from our board and from Scouts. So get on the air. 14655 is a common frequency that they use. They're also doing 6 meters. You got some more information?
Yeah, just 2 p.m. today it starts, ends 11 o'clock tomorrow night. You've probably all seen there's been a lot of email traffic on it with calling frequencies and whatnot. So get on, it'll be active, should be a lot of fun. If nothing else to give thanks, but it's going to be a snowy weekend, so.
You got time to stay home.
Radio
It's on 2 meters, all the VHF bands, but some of us have got these brand new radios that got 6 meters on them.
Yeah.
And I use my 80-meter loop on 6 meters. It works fine. I've made contacts. So get on there and find out whether your radio works on 6 meters and 2 meters, mostly simplex, single sideband, FM, any mode you want. Okay?
Oh, one other thing, Tim, the HJD, N2 HJD is going to be a repeater that's available for coordinating contacts and times.
Okay.
N2 HJD. I think it's N2, yeah, N2 HJD.
Yeah.
And the E is, it's linked and it's cross band multiple.
Good. Karl, Heinz Heinz, you got anything more to add? Thank you very much.
My weather station. Apparently it's snowing. 15.8 degrees, wind of 5.6 miles.
Does it have the slippery index for getting into your driveway and?
It's only slippery if you fall. I tell my wife that all the time, don't fall,
yeah.
it's not
But you
slippery.
get nice information like this, the temperature over time,
Yeah.
the wind speed over time. the
You
wind
need
direction.
to work on your wind speed. It's kind of variable.
Yeah.
Well, thank you. Thank you very much.
Thank you.
Any questions?
Does this Raspberry Pi software do the plotting, or is that a weather
This is
underground?
Weather Underground.
Weather Underground does
But
that.
there is software for the Pi to do that kind of stuff. Python libraries to do that. So when you look here, this is all done in Python.
Nice sheets over here.